when I do this, I'm not going to have you. You should practice graphing them so that you know what it looks like, the graphs look like. In class, I'll do it, but when I'm doing tests, I'm going to say, what is the interval, period, amplitude, and phase shift? And that's going to be, we'll get to that in the later sections, the phase shift and so on. And that's what I'll ask for. So we're on page 154 and number 24. Y equals 2/3 x. Let's see what they're asking. It says graph each function over a 2-period interval. Give the period amplitude. And I'm going to actually do interval, period, and amplitude. So we do amplitude on this, and amplitude, remember, is, let's just, the amplitude is going to be the A. This is amplitude. And then this B is going to be involved with the period. So affects period. Okay, so the amplitude then is going to be what? Yeah. Period is going to be, technically it's this value here over 2 pi. I didn't say that right. It's going to be times the invert of that. So this is going to be 3 pi. And then the interval. Now, when you do the interval, it will check to make sure whether the period is right. So when you do interval, always go 0. Sine and cosine are going to be 0 to 2 pi. And then when we do secant, cosecant, tangent, cotangent, it will have its interval, which won't necessarily be the same thing. But here we'll put 2/3 x. And then we want to get 2/3 by itself. So then you go 3 over 2. And then it's going to be 0 less than or equal to x. And then you can see this comes out. And then if you wanted to figure the period here, you would subtract this from that. And but the interval, this is going to be the interval. The reason I'm doing this is that sometimes when you get a phase shift, this won't stay at 0. It'll go different. And then in order to make sure that your period is right, then whatever this is, you want to subtract from that, and that tells you how far, what it's doing its wave over. So look at 30. Okay. Yeah, I should. If I were going to do that, yeah, you'd either go from minus 3 pi to plus 3 pi, or else you'd go 0 to 6 pi. So I guess I should do that. And I'm gonna go 0 to 6 pi. Because I want it to go up a little bit. I don't know why I don't. I'm going to call this 3 pi, and then 6 pi. Now, what I want to do, I want to mark this off as half, then half of this, half of this. And then half, this is going to be 3 pi over 2, right? Because it's 1/2 of that. And this is going to be half of that, which is 3 pi over 4. And then this is going to be 3 pi over 4 above this, so this is 6 pi over 8, and that'd be 9 pi over 4. No, 6 pi over 4, add 3 pi over 4, 9 pi over 4. And then this is going to be 12 pi over 4, correct? That's 3 pi over 4. Then I'll add 3 pi over 4 to get this. 15 pi over 4. And then I add 3 to it, that's 18. I'm going to write 18 pi over 4 and then reduce it down later. Because then this is 21 pi over 4. And then it's 24 pi over 4. But these two will reduce down. So this one, if you were talking about it, this one is the only one that reduces. So you would call that 9 pi over 2. If you were trying to lay it out. And then we're going to go, this amplitude is 1. So this is going to be 1 and minus 1. And then the sine, this is 1 period. So the sine curve starts out at 0, right? Goes to the maximum at 1/4. 0, minimum, 0, maximum, 0, minimum, 0. Oops, gotta go through here. Got worse as it went along. Okay. I want to do 36 rather than 30. I think you can figure these out. 36 says 3 over 2 pi x. So the first thing is amplitude. And that's going to be what? Absolute value of 3. Now, the reason to do absolute value, because that's a negative, it's still 3, right? And then the period. And I'm gonna do interval and then kind of figure the period out from the interval. So I set my interval 0 less than or equal to, which is less than or equal to 2 pi, and I put this whole thing in there, 2 pi x, and I divide 2 pi. So then this becomes 0 less than or equal to x, which is less than or equal to 1. So the period is 1, and the interval is 0 So now if I set this up, ooh, nothing really coming out so good. Gonna have to go 1, 2, 3, 2. So this is +3, this is -3. It's not perspective, but this is 1, that is 2. And I go half the way, 1/4. This is 1/2, 1/4, 3/4. 1 1/4 is going to be 5/4. 6/4 is reduced down. 6, 3, 6. How's that? That's 3/2, isn't it?
Mm-hmm.
And then 7/4. Okay. And then it's sine once again, so it starts out here, goes to its maximum, back there, down to its minimum, there, maximum. Something like that. Okay. You can do, that's pretty easy, isn't it? Then next, that 41 through 46, it says each function graph is of the form y equals a sine bx, or y equals a cosine bx. B is greater than 0, so they're not letting it be a rotated, right? It's just a regular sine and cosine. It's not something that's inverted. Determine the equation of the graph. So we go 42. Now what you want to do is look at that. What? They're saying, oh, B, A, it could be an inverted graph, right? Because they're not saying A is greater than 0, they're saying B is greater than 0. So 42, that's an inverted sign, isn't it? So it's going to be y equals, it's a negative, because notice, reason, why do I say it's a sign? It's 0. It's starting out at the 0, right? And then the inverted is because it goes down rather than up. And then the amplitude is going to be 2, so it's a -2, right? And then it's sine. Now, notice that its period is pi, right? So, well, no, I don't think that's right. The period, what it is, I want to think of how. The period is pi, and that's equal to 2 pi over b, right? Isn't that right? So now you want to know what b is. So you go up here with b, you go 2 pi and divide by pi, right? Which is 2. And I'm writing the form a sine bx. So what this has to be, 2x. right?
So you have pi equals 2 pi over b.
Yeah. Well, see, this is the I wrote it backwards of what the formula back here says that your period is the way you do it is 2 pi over b. This is the formula for period right here. Yeah, yeah. Well, this is the formula for 2 pi. I mean, formula for period, right? But we can see that the period is only pi. I should have wrote it the other way around. I should have wrote it this way. 2 pi over b is the formula for period, but the period of this item is pi. I just wrote this backwards. I said you can see that the period of 42 is pi long, right? So I wrote that. But that is equal to 2 pi over b in terms of formula. So now we can calculate what this b has to be in this.
Yeah,
Does that make sense?
I was also looking at there's 2 periods here.
It's 2 period long.
Yeah.
Yeah. A period is when it runs through one cycle. Yeah. And that's a 2 period long. So here's what they want. Answer. Now, probably what you're talking about is here, 44. Now, what's that going to be? Is that going to be a sine or a cosine? That's a cosine. See, so what we got is y equals a cosine bx. Now, the a is going to be what? Yeah, it's absolute value of 3 is what I should have wrote absolute value of 3 before. Now that is a regular cosine wave because it's starting out at its maximum. But what is the length of the period? What is the actual length of the period? 4 pi, because they're only showing you half of it, right? I mean, normally a cosine starts out, goes down, comes back up, and goes here. But they've only shown you how much of it. They've only shown you here, from here down to here. And they said this is 2 pi long, so over here has to be 4 pi. Okay, everybody? Okay, see in the book on 44, they've shown you this thing right here, right? Which is half of the cosine wave. And that half of that cosine wave is how long? 2 pi. So the whole wave takes 4 pi. So the period on that one is 4 pi. So then I say 4 pi, and now I want to calculate what b is. Well, what the period would be, this is the general formula for the period, right? 2 pi over b. But that's actually 4 pi. So what I want to do to solve for b, I'm going to multiply both sides by b, correct? And then divide both sides by 4 pi. So then this goes out, and I have b by itself on this side. Pi's go out. This goes, b is 1/2, right? So then the rest of this is cosine 1/2 x, because I'm substituting into this. That makes sense? We can look at 46. Now, what does that look like? It's an inverted cosine wave, isn't it? So what we're going to be doing is finding A and B in this form. Now, the letter A has got to be a negative, right? And then negative what? Yeah, does everyone agree? It's negative 3. So when I write this, I've got this, y equals negative 3 cosine, and now I got to figure out B. Now, the B, how long is the period in that thing? Where's one cycle? It has to, where does it go back down to the 0, to a minus 3? Pi over 2. So the length of the period, actual length of the period is pi over 2, but that's going to always be, the formula for that is 2 pi over b. Whatever that b is, you're always going to divide it into 2 pi. So if we solve this for b, then we got what b is. So b is going to equal 2 pi, and then this is going to be inverted, right? Times 2 over pi. So b is 4. Put it in there, and there's the formula for that. Does that make sense? See, this is the formula for the period. This is what the period actually is. So we want to know what b would have to be. Okay. All right, then that'll finish that. Now this is 4.2. This is translations of the graph of the sine and cosine functions. Now notice we're just talking about sine and cosine in a horizontal translation. That's moving it left and right, is called a phase shift. And the argument is, that you notice it's x minus b. So what you do is y equals sine of x minus b. This is the phase shift. Y equals cosine x minus b. That's where your phase shift comes in. Occurrence. And the phase shift, to me, the easiest thing to do is to figure out your interval. Because if later on we're going to have a period shift where there's going to be a value b minus d, and that b is going to be involved in that whole interval over which you're going to place that thing. So it's best to calculate the phase shift according to interval and really concentrate on interval for the purposes of graphing it. Okay, now they're talking on 161, further guidelines for sketching graphs. And this is the first method. It says find the interval whose length is 1 period by solving the 3-part inequality. You see what they're doing is that interval, you're starting always, the sine and cosine always has a 0 to 2 pi. then you put whatever is in here in between and get x by itself. That'll give you a phase shift, it'll give you a period, it'll do all of that at once. And it says step 2, divide the interval into 4 parts. Number 4, evaluate the function for each of the 5 x values. So if you divide anything into 4 parts, you always have 5 points, right? Beginning and ending. And it says plot the points in the step according to the sinusoidal curve that you're doing with the amplitude of the absolute value of A. Draw the graph with it over additional periods if you need to. Okay. I think the best thing to do is just do some problems. On page 164. Then number 2. And it says match each function with the graph A through H. Maybe what we can do with this is just look at it and graph it. Now, what the comment that I want to make on this thing is, maybe I'll just look at 1. Because it probably y equals sine of x minus pi over 4. Now, that's a phase shift, and it's going to go left or right. Now, when you look at that, you might say, well, that should phase shift it to the left. It doesn't. It phase shifts it to the right. Because remember, the sine function starts out at 0, and what value of x will make this whole thing 0? Positive pi over 2. So what it's going to do is it's going to take your 0 position and be over at pi over 2. Pi over 4, excuse me, pi over 4. Because what makes this 0 inside here is pi plus pi over 4. So that'll start out at 0. Remember, see, when we do our normal sine function, what we're doing is we're inputting these values, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, when we go, what is y when sine of 0, this value x is 0? Well, the sine at 0 is 0, right? So we say the ordered pair here is 0, 0 height. Y is 0 height. When we go to here, we go y is equal to the sine of pi over 2. And what is the value of pi over 2? It's 1, right? And so we get up here to 1 height. And then when we go sine of pi, we say is 0, and the sine of 3 pi over 2 is a negative 1, and the sine of 2 pi is back at 0. Remember when you go around this unit circle. If you want to go back to the unit circle, I think didn't I give you that sheet? Okay, look at the unit circle, and you look at 0, and then you look at the ordered pairs. Which ordered pair is the sine? It's always cosine sine, isn't it? The x value is the cosine and the y value is the sine. So what is it at 0? 0. What's the height of the y? What's the height of the y-axis on the unit circle when you're right here? 0 height, right? What's the height of it when you get up here to pi over 2? It's at a +1, right? The height is +1. What is the height at pi? 0. What's the height at 3 pi over 2? -1. So it goes 0, 1, 0, -1, and then at 2 pi it's 0, right? It's 0, 1, 0, -1, 0. Correct? Now, notice it's sine of 0. What makes this value, when this is rather than just x minus pi over 4, what makes that 0? Pi over 4. So what it's doing is it's shifting this out here to pi over 4. And that's where this value is 0, and then therefore the sine is 0. So it's phase shifting it over here. And it'll shift it out this way. That make sense? So intuitively, this is what you got to go counterintuitive. When you go sine of x minus pi over 4, it shifts it right, not left. Because intuitively, you'd think, well, negative is left, positive would be right. It's backwards. Negative is right, positive is left. Because if that were plus pi over 4, to make it 0, what would your x have to be? Negative pi over 4. It would phase shift it left. Yeah, Corey?
So this one, the x is the phase shift?
Well, what it is this whole thing is phase shifting it to the right. And this value right here is the phase shift. Now, another way of looking at this is saying x plus and it's x minus. This is the phase shift, because then if it phase shifts it left, it's x minus a minus pi over 4. If you say it's x minus, and then what is inside the bracket, that says it phase shifts it to the right. If it phase shifts it to the left, it's x minus a minus pi over 4. This one would actually turn out to be sine of what? X plus pi over 4. That's phase shifting it left. See, do you see what I'm, when you put this as a minus and then put in a bracket and say, what's this got to be? This is a right phase shift when actually it's x minus pi over 4. But if you go minus a plus pi over 4, the plus pi over 4 is a phase shift. If it's a left phase shift, it's x minus a minus pi over 4. But that turns out to be x plus pi over 4. Then that tells you, if you look at it this way and put it in brackets and then say, what is this thing got to be? Then that's going to tell you the phase shift. In other words, it should say sine of x minus the quantity d. And d when it is x minus pi over 4, d has got to be positive pi over 4. If d is negative, then it's going to be x plus pi over 4. X is the variable that you're dealing with, but then you're putting values of the x-axis in, and as you put values of the x-axis in, it's going to give you values that are going to range from 0 on up. It's not necessarily the starting point. It's just when you do the normal sine curve, you usually associate 0 to 2 pi as one sinusoidal curve, one sine curve. Where at 0, whenever whatever's in here is 0, you're going to have a 0 height. But when you go x and you, in whatever this thing is, whenever you change this value, it's going to change the position of x for which this total thing is 0. And that phase shifts you. And I'm gonna try talking to you about it this way. Here is the general form of a that B is, I think, on the inside. This is going to be a period. That's going to affect your phase. This is going to affect your amplitude. Now, to get to the problem that we are at right now, which problem are we dealing with? Number 1, where it says y equals sine of x minus pi over 4. A has to equal 1. B must equal 1. And D has to equal positive pi over 4. Is that right? To go into this general form, to get this value, A must be 1. B must be 1. And D has got to be a plus pi over 4. So this says the amplitude's 1, the period is same as the sine, 0 to 2 pi, and the phase shift is a positive pi over 4.
With you so far.
Okay.
But is that it, or?
Yeah, then what we want to do is take number 1, and it's saying match it with A, B, C, D, E, F, G, H. And if this is a normal sine curve, phase shift to the right by pi over 4, amplitude 1, that's got to be D. Is that right?
It's the only one that starts.
It's the sine curve starts at pi over 4. Amplitude of 1. So then number 2, which way, when you try to put it in here, when you do in number 2, and we're doing number 2, which is y equals sine of x plus pi over 4. The A has got to be what? This A has to be the B and the D negative pi over 4. Because if you put a minus pi over 4 here and take a minus times it, it's a plus, right? So this one has an amplitude of A. The period is 2 pi long, and it phase shifted to the left by pi over 4. Now, that means it goes from minus pi over 4. It don't go to 2 pi. It goes pi over 4 back from 2 pi, right? Just like this previous one, notice it didn't go from pi over 4 to 2 pi. It went to 1 pi over 4, 1 greater than 2 pi, right? So now which one is it? It's a sine curve, right? You're thinking G? Okay, does everyone agree? Okay. So then let's, number 3. And remember, once again, it's a cosine dx minus d, where this one's y equals cosine x minus pi over 4. So the a is going to be what? 1, d is, and the d pi over 4. So which one's the cosine curve shifted what? Right, pi over 4? Okay, everyone agree? Okay. Now, notice 5, 6, 7, and 8 have got a little bit different thing. What we have is on 6. Now then, the general form we're looking at, it's C plus, and this is going to be sine A sine bx minus d. Now C will translate this thing up or down. So the horizontal axis is actually going to go up or down by that C distance. Right? So look at y equals -1 plus sine of x. So C is going to equal what? -1. A is B and B 0. Right? So there's no phase shift. This is just it's taking the horizontal, the middle line down 1 unit, and then it's going to have that same shape. So which one? And it's going to have to be the cosine curve down 1, right? So which one is it? Is this is sine? Okay, this is sine. So it's the sine down 1. So which one is it? Okay, E. So this is kind of the total that we're going to have. I'm pretty sure that B is inside there. No, they have it on the outside. So, but it's still going to be that same thing. This is supposed to be this way. But on the previous ones, it's not going to make a difference. That B is still going to be there, and that's going to affect the period. All right. This exercise is 9 through 12. It's saying match each function with its calculator graph on the, I guess. What do you think, Ken? Which one would you match it with? Which is it phase shifted which way? To the right, pi over 4, right? Still has, yeah, it looks like B is probably the right one. 12 would be what? Cosine curve down 1, wouldn't it be? That's what I'd think. D, don't you think? I'll do 16. Now these are the way I'd lay things out. What they want to do is they want you to find the amplitude, the period, phase shift, and I'm going to do interval also. Y equals 2 sine of 3x minus 4. Amplitude, period, interval, phase shift. Now the amplitude's pretty easy. It's going to be what? Yeah. Now what I would do is I would calculate the interval. Now notice sine is going to be 0 less than or equal to, which is less than or equal to 2 pi. Put your 3x minus 4 in here. And then get x by itself. So I'm going to add 4, right? 4 less than or equal to 3x less than or equal to 2 pi plus 4. Then I have to divide by 3. So it's 4/3 less than or equal to x, which is less than or equal to 2 pi plus 4 over 3. So there's your interval. Now, what is your phase shift? It's right 4/3, isn't it? It's moved it from 0 to 4/3. Now your period is going to be, what you do is you take this away from here. So it's 2 pi over 3 plus 4 over 3 minus 4 over 3. It's going to go 2 pi over 3. In this particular case, it's going to be this 3 into 2 pi. So these are your, if you were going to graph it, you would start at 4/3 and then go to 2 pi over 3 plus 4/3. Divide that into half, then divide each one of those things into half. And figure it out. But that's what they're wanting us to do, is amplitude, period, phase shift, and I would suggest you do the interval. All right. When we get through with 4/4, then we'll have another test.